Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the autocorrelation function of the random process and autocovariance of the random process x of t. The example is, consider a random process x of t is equal a cos omega t, where omega is a constant and a is a random variable uniformly distributed over 0, 1. Find the autocorrelation function and covariance of x of t. Coming to the solution, given that the random process x of t is a cos of omega t, here omega is a constant value and a is a random variable. So that random variable a is uniformly distributed over the interval 0, 1. So we know that the standard expression of the uniform probability density function is 1 by b minus a for x is equal to a to b. So using that standard expression, so the uniform random variable of a over the interval 0, 1 is f of a is equal to 1 by 1 minus 0 is 1 for 0 to 1. So first find out the autocorrelation function of the random process x of t. So we know that the autocorrelation function of the random process x of t is Rx of t1 comma t2 is equal expectation of x of t into x of t plus tau. X of t is a cos of omega t. Okay, so Rx of t1 comma t2 is equal expectation of x of t1 into x of t2. So now here x of t is a cos omega t. So x of t1 is a cos of omega t1 and x of t2 is a cos of omega t2. So a into a square. So now here the a is the random variable. So x of cos of omega t1 and cos of omega t2 are the constants that are written before expectation, which is equal Rx of t1 comma t2 is equal cos of omega t1 cos of omega t2 into expectation of a square. So first separately calculate expectation of a square, and after substitute that value into this equation, finally we get Rx of t1 comma t2. So now expectation of a square is equal integral 0 to 1 a square into f of a dA. So given that the range of the interval is 0 to 1. So now here the density function f of a is 1, which is equal integral 0 to 1 a square into f of a is 1 into dA. A square into 1 is a square, integral a square dA is a cube by 3 over 0 to 1. Now substitute upper value of a and lower value of a. So 1 cube minus 0 cube. 1 cube is 1, 0 cube is 0. So expectation of a square is equal to 1 by 3. And substitute this expectation of a square value into this equation. Therefore, the autocorrelation function of the random process x of t is Rx of t1 comma t2 is equal 1 by 3 cos of omega t1 cos of omega t2. Next, find out the autocovariance of the random process x of t. So we know that the autocovariance of x of t is covariance of t1 comma t2 is equal expectation of x of t1 into x of t2 minus expectation of x of t1 into expectation of x of t2. So this is the equation of autocovariance of the random process x of t. So now here in this first term already calculated, that is correlation function of the random process, that is already calculated, and its value is 1 by 3 cos of omega t1 cos of omega t2. And now separately calculate expectation of x of t1 value and expectation of x of t2 value, and after that substitute all the values into this equation. Finally we get the autocovariance of the random process x of t. So now we can determine expectation of x of t1. So given that the random process x of t is a cos of omega t, so x of t1 is a cos of omega t1. So now here a is the random variable, omega is the constant. So cos of omega t1 is written before expectation into expectation of a. The expression of the expectation of a is integral 0 to 1 a into f of a dA. So now here from the given data, the uniform density function of the random variable a is 1. substitute f of a is equal to 1, so which is equal to expectation of x of t1 is equal cos of omega t1 integral 0 to 1 a into 1 is a dA, integral a dA is a square by 2 over 0 to 1. Now substitute upper value of a and lower value of a, which is equal cos omega t1 into 1 square minus 0 square by 2. 1 square is 1, 0 square is 0. So therefore expectation of x of t1 is equal 1 by 2 cos of omega t1. Similarly calculate expectation of x of t2. So expectation of x of t2 is equal, so given that x of t is a cos omega t, x of t2 value is a cos of omega t2. A is the random variable, so this RHS term is arranged as cos of omega t2 into expectation of A, and expectation of A is integral 0 to 1 a into f of a dA, and f of a value is 1 from the given data. A into 1 a integral a dA is a square by 2. Now substitute upper value of a and lower value of a, we get expectation of x of t2 value is 1 by 2 cos of omega t2, and substitute all these values into auto-covariance of the random process x of t expression. Therefore, the covariance of x of t is covariance of t1 comma t2 is, and the first term is correlation of the random process, and its value is 1 by 3 cos of omega t1 cos of omega t2 minus expectation of x of t1 value is 1 by 2 cos of omega t1 into expectation of x2 value is expectation of x of t2 value is 1 by 2 cos of omega t2. 1 by 2 into 1 by 2, 1 by 4, so that is equal 1 by 3 cos of omega t1 cos of omega t2 minus 1 by 4 cos of omega t1 cos of omega t2. So now take the LCM. The LCM is 12. So 4 and after taking the LCM, the numerator term is 4 cos omega t1 cos omega t2 minus 3 cos omega t1 cos omega t2. So which is equal to cos omega t1 cos omega t2 by 12. So this is the auto covariance of the random process x of t.